In our first visualization system, we identify 3 roles: keyword, author, and tag. For each role, we create a list of its important instances and a network of these instances. A message panel is used to display messages related to an instance of interest. We identify different types of content by creating a classification tree, in which each node represents a type. First, we create a node called Event Related and a node called Event Unrelated under the root. Then, we notice that different author posted different type of content and most authors just posted a certain type. Therefore, we can quickly build the classification tree by the author. For example, Kronoskwath always posted chicken soup. So we create a node named Chicken Soup under the Event Unrelated node and add all his messages to this node. Abila Post, Homeland Illumination and Kronos Star are media with high retweets. They all focus on recording the process of events. So we create a node called Media and assign all their messages and forwarded messages to the node. After checking the top 30 authors, we build a classification tree with 8 types of content, including witness reports, media, POC opponents, POC supporters, chicken soup, nonsense junk, advertisement, and typical chatter. To understand and compare the characteristics of these types, we develop another visualization system. The well-separated distribution of types in the left map demonstrates the rationality of the built classification tree. The detail panel shows statistics of a focused type, such as the temporal distribution of messages, feature words, and sentiments. We found that witness reports mainly focused on the event of hit and run, hostage and standoff, while the media paid more attention to the fire event. Compared to witnesses, media prefer a neutral mood to objectively record events, and they have a much higher influence. We then develop a third system that allows the analyst to analyze how risk evolves by drilling down into sub-events and understanding their impact on risk. Initially, the system provides an overview of risk migration among the 3 events. And then the analyst can select an event of interest and create a series of word clouds with different time windows to find clues about sub-events. Next, the analyst can extract, name, and classify sub-events based on these clues. Then, a milestone timeline is automatically generated to provide a better understanding of event evolution by explicitly displaying the names of all extracted sub-events. Finally, the analyst can draw a curve to present the changes in risk that they perceive. Take the fire event as an example. Focusing on risk of personal injury and property damage, we can see that the risk has 2 large rises and 2 rapid declines. The first rise occurred in the first half hour of the fire because the fire was spreading and the safety of residents was unknown. The second rise occurred at the end of the event because an explosion was reported. For retrospective analysis, we will send first responders to the fire department because we believe that without the fire, the subsequent hit and run, hostage and standoff event would not happen. In map, we link the calls related to the latter event in temporal order, resulting in a trajectory of the black van. We then note that the van was first seen hitting a bicyclist is just near the apartment. And prior to the hit, the fire in the apartment was growing rapidly and the police were evacuating the residents. Therefore, we conclude that the kidnappers were initially hidden in or near the apartment but were forced by the fire to flee with the hostages. In other words, the fire event is a trigger for the event of hit and run, hostage and standoff.